So now we would like to talk about how to evaluate the interval estimators. So in this case, two things need to be considered. So first we need to consider the coverage probabilities. If coverage probability is are too low, then we don't have much confidence on your interval. So we need to have coverage probabilities as large as possible. And secondly, we need to consider expected length, which is the average length of the interval. So we define the expected length when we start to talk about this interval estimator. So the expected length is the average length of the interval. So length of interval is the distance between the upper bound and the lower bound, and we would like to have the smallest expected length possible. So the reason why we would like to have the shortest expected length for the interval is for fixed alpha, the 1 minus alpha CIs are not unique. So we use the two quantities alpha 1 and alpha 2 to define the 1 minus alpha confidence interval. Then there are infinitely many choices of the alpha 1 and alpha 2. And then in that's the case, if we have the smaller expected length, that means that we have the more precise guess or formally the estimate for the parameter mu. So we would like to have the shortest expected length as much as possible. So So among many choices, we want to minimize the expected length, which means that minimize expectation of ux minus lx. So we have the IID normal, where the sigma squared is known, and we like to use pivotal quantity, which is the z statistic, x bar minus mu divided by sigma divided by square root of n. We choose we have we would like to choose one A and B such that the probability that Z is between A and B is 1 minus alpha, and then 1 minus alpha constant interval is given by x bar minus b times sigma divided by square root of n. That's the lower bound, and upper bound is x bar minus a times sigma divided by square root of n. So you can see that there are infinitely many 1 minus alpha component interval depending on A and B. So you can see that the so first question is the length of the interval. So the length is b minus a times sigma divided by square root of n. And then the second question is how to choose A and B to make a length the smallest. So the expected length is also 1b minus a times sigma divided by square root of n. So the sigma is known and n is fixed, so we would like to So we would like to minimize the B minus alpha subject to constraint. The area under curve between A and B is equal to 1 minus alpha. The curve is the PDF of C, which is the standard normal. So we would like to minimize B minus A subjects to the constraint, where the constraint is the probability between A and B is 1 minus alpha. So in this case, so how to optimize length? So there are two cases. Unimodal case. So when you say the unimodal, it means that there is only one mode. So unimodal means the fx is unimodal where exists So fx is unimodal. There exists x star such that fx is non-decreasing for x is less than or equal to x star, and fx is non-increasing for x is greater or equal to x star. So this is unimodal because there is only one peak, and then before the peak, this fx is increasing, and after the peak, the fx is decreasing. So unimodal means that you have only one peak, and then before and after a peak, your function's monotonicity, I mean your PDF of the monotonicity is going to be different. And then this is bimodal. You have two peaks. And then you have one peak before the first peak. Before the first peak, it is increasing, and after the first peak, it decreases, and then after the middle point, it increases again, and after second peak, it decreases. So in this case, we have two hills having two peaks, which we call bimodal. First example is unimodal. Second way is to use the Lagrange multiplier method if you do not have the unimodal distribution. This is quite complex method, so I will not explain this method. So I will concentrate on the case 1, which is the unimodal case. Let's say we have the unimodal PDF. If interval AB satisfies So the probability of the x between a and b is 1 minus alpha, and fa equal to fb, and they are greater than 0, which means that the PDF value, the two endpoints are the same. And then there exists one so I mean, it's unimodal case. There's only one mode, and then the mode is between A and B. Then A and B is the shortest among all intervals that satisfies the first, which is the probability that x is between A and B is the 1 minus alpha. So proof. So the idea of the proof is that when you pick up the shorter, and the interval whose length is shorter than the A and B, that interval does not have 1 minus alpha confidence coefficient. So we have we have to prove only for A is less than A. because a prime is less than a, because the proof for a prime is greater than a is going to be similar. So and we have, in this case, we have two cases. So the first case is b prime is less than or equal to a, then a prime is less than b prime, less than or equal to a less than or equal to x star, and less than or equal to b. Because we have the mode between a and b, and then we only consider case the b prime is less than or equal to a, and then also we only consider the case a prime is less than a. So a prime is less than b prime, less than or equal to a, less than or equal to x star, and less than or equal to b. So which is we have this. So by using picture, we can draw like this. So if you consider area between a prime and b prime, so we would consider area between a prime and b prime, which is probability that exists between a prime and b prime, then this is less than or equal to probability integral of between a prime and b prime f b prime dx, because this three dots in the reverse the triangle shape means the because. So because fx is non-decreasing for x is less than or equal to x star. So if you look at this area between a prime and b prime, since so you can see that this since the b prime is b prime is greater than a prime, so if you draw a rectangle between a prime and b prime, and that area of rectangle is clearly bigger than or at least equal than the area on the curve between a prime and b prime. So this is equal to B prime A prime, and clearly f is non-decreasing for x is less than or equal to x star, and A is still less than or equal to x star. So you have that so fb prime times b prime minus a prime is less than or equal to fa times b prime minus a prime. So you can think this rectangle. So since a is greater than fb prime, so your rectangle based on the b prime, a prime, and fa is clearly larger than the rectangle than the fb prime and b prime minus a prime. And then that's less than f a times b minus a, because a prime and b prime has a shorter length than AB, so you can clearly see that this rectangle based on A and B is clearly greater than rectangle based on A prime and B prime. So this is equal to A FA dx, and then the same reason for the second argument. Fx greater than fa for a, x, and b. So since fx is non-decreasing when x is less than or equal to x star, so a is less than or equal to x star, so so you can see that the integral between a and b, fx dx, is greater than the integral a and b, fa dx. So this rectangle here is less than this 1 minus alpha, which is area between under curve a and b. This 1 minus alpha. So the constant coefficient based on a prime and b prime is less than or equal to 1 minus alpha. So in this case, the interval based on a and b is the shortest among interval that satisfies the 1 minus alpha, because if for interval shorter than the a and b, the a prime b prime does not have the coverage 1 minus alpha. Then let's consider b prime is greater than a. Then we have this. So here it doesn't matter that the x star is greater than b prime or less than b prime, it doesn't matter. So we have a picture. So you have b prime in here. In this case, this has 1 minus alpha. And then if you have this case, your area between a prime and b prime is integrating b to a to b first, and then you need to subtract from you need to add the integral from a prime to a and then subtract the integral from b prime to b. So you need to add this part and you need to subtract this part. So in that case, this is and then since since a is less than or equal to x star, so and then in that case f is increasing or non-decreasing, so you have this inequality. You have this. So area between a and a prime fx dx is less than or equal to fa times a minus a prime, so which means that your area, this area, is less than or equal to this rectangle. Then so fb fx the integral of b between b prime and b fx dx is greater or equal to integral b to the b prime fb dx, which is fb times b prime minus b prime. So this part is bigger than the rectangle based on fb and b prime and b. So you can see that this rectangle having the side b prime, and b, and the fb is that rectangle's area is smaller than the area under curve between b prime and b. So we have this. And that was a bad assumption. So FA equals FB. This, I'll say, this is a star. Star is we have this rearranging, but we have this b prime fa times b prime minus a prime minus b minus a. So we have this because the fa and fa would be by assumption. So if we say fa equal to fb equal to fa, then we can make these together and calculate it. So this is going to be prime minus parenthesis b minus a, and this is less than 0 because a prime and b prime has shorter length than the a and b. Hence, so we have, so this quantity is less than 0 by derivation on this one. So this area is the smaller than fa times a minus a prime times b fb times b minus b prime. So by assumption, we can see that this is equal to fa times b prime minus a prime minus b minus a. That's less than 0 because the interval AB is longer than the A prime, interval A prime and B prime. So this coverage based on interval A prime and B prime is less than 1 minus alpha. So conclusion is that in both cases, if in both two cases, if we consider A prime B prime, interval A prime B prime which has the shorter length than A and B, interval A and B, then the coverage based on A prime B prime is less than 1 minus alpha. The shortest interval that achieves the coverage, the A and 1 minus alpha, is A prime and B prime. So no interval exists which is shorter than A prime B prime and they achieve coverage the 1 minus alpha.